All right, let's talk a little bit about simple and compound interest. To calculate simple interest, so we have to work with money every day. So when you're balancing your checkbook or calculating your monthly expenditures, requires only arithmetic, but we start saving, planning for retirement, or looking for a loan, it gets slightly more complicated. Discussing interest starts with the principal, or the amount that your account starts with. It could be starting an investment or the starting amount of a loan. Interest in its most simple form is calculated as a percentage of the principal. For example, if you borrowed $100 from a friend and you'd agree to repay it with 5% interest, then the amount of interest you would pay would just be 5% of the $100. So there'd be 100 times 5%, which either would be 0.05 or 5 over 100, and that would give you $5. The total amount you would repay would be $105 because you would add the interest onto what you borrowed originally. So the original price plus the interest is what you pay back. We use the mathematical notation to summarize this calculation. So we'll let P sub 0, or we in math say it P naught, let P naught be the principal, the starting amount. So anytime you have a subscript of 0, that's an initial amount, like when T equals 0, that's your starting amount. R is the interest rate in decimal form, and we're going to let I be the interest. So for simple interest, then I equals P naught times R. So a friend asks you to borrow $300 and agrees to pay it in 30 days with 3% interest. How much interest will you earn? So my principal is $300. 3% is my rate, but that's the same as 0.03 because we have to use a decimal when we do calculations with interest. And they want to know how much interest will you earn. Well, if it's simple interest, I equals P naught times R. So it'd be $300 times 0.03, and that would give me $9. So if they borrowed the $300, pays it back in 30 days at 3%, you will make $9 on that investment or that loan. One-time simple interest is only common for extremely short-term loans. However, it can be used for longer-term loans where simple interest is evaluated based on the original principal amount after each set period of time. So if you're going to calculate simple interest over time, we're going to let P naught be the principal, R the interest rate in decimal form, T the time, and I is the interest. Then I equals P naught times R times T. So a friend asks you to borrow $300 and agrees to repay it with a 3% simple interest per month. How much interest will you earn after 5 months? So it's like the last one, except for now we have a time frame. So P naught is $300. Our interest rate is 3%, but we have to make that into decimal form. You could also use a fraction if you prefer to do 3 over 100. And my time is 5 months. So now I'm going to put this into my equation, and I get I is equal to 300 times 0.03 times 5. I put that in my calculator. I get $45. So you would earn $45 after 5 months. So let's look at this other example. Sammy's bank account earns 4% simple interest per year. If Sammy deposits $500, how much simple interest will she earn in 1 year? Round your answer to the nearest dollar if necessary. So I know that my initial amount, or P naught, is $500. My rate is 4%, which is 0.04, and T equals 1. So my simple interest formula, I equals P naught times the rate times time. And when I put that in my calculator, I get I is equal to $20. So Sammy will earn $20 in interest on her investment. So things don't stay simple long in math. So now we have compound interest. There are actually other types of interest, but this would be the next more complicated one. So with simple interest, we are assuming we pocketed the interest when we received it. In a standard bank account, any interest we earn is automatically added to our balance, and we earn interest on that interest in future years. This reinvestment of interest is called compounding. So I think you may have heard, oh, I just compounded my mistake. I just compounded this, meaning you add upon it. And so compounded interest is you add your interest back into what you already have. So suppose that we deposit $1,000 in a bank account offering 3% interest, compounded monthly. How would our money grow? The 3% interest is the annual percentage rate, or APR, the total interest to be paid during the year. Since the interest is being paid monthly, each month we will earn 3% divided by 12, or 0.25% per month. In the first month, the principal, P0, is $1,000, and the rate is 0.0025, or 0.25%. Remember, we can't do anything mathematically with a percentage unless it's in decimal or fractional form. Therefore, the interest earned during this first month, if I put the information in, will be $2.50. Therefore, the total amount at the end of the month is $1,000 plus what we earned, which was $1,002.50. So we can go back and do this every month and add it to what we had, and that's a lot of calculations. Or we can use this formula to figure out what we would have at any time. So this general equation that allows us to find the amount of money in the account after a certain amount of time is this. Now, I've seen books, and even Newton Alta is not consistent in what they call certain things, but that's okay. The formula is still the same, and I tried to use the one that is more intuitive, like T for years, T for time. So if you see slightly different letters in there, don't freak out, because it is still the same. It's just there's not a lot of standardization between curriculum and textbooks. So this formula is P sub T. So this is the balance after T years is equal to P0 times 1 plus the interest divided by the compoundings per year, all raised to the NT power, where N is the compoundings and T is the time in years. So this is a handy little thing here. You might have this around while you're doing your homework. If compounding is done annually, it's once a year, then N equals 1. If compounding is done quarterly, because there's 4 quarters in a year, then N is equal to 4. If compounding is done monthly, then your N is equal to 12. If the compounding is done daily, then N equals 365. And if the compounding is done semi-annually, that's twice a year, N equals 2. Okay, you could also have weekly. It's in one of our problems that's coming up, but it does say how many let N equal this. So if they're going to throw a curveball at you, typically in your homework or on the test, it will tell you. But this is just a good thing to have around because you're tired, and I'm like, quarterly, what's that? Well, sometimes that can be confusing because a quarter is 3 months, right? But you have 4 quarters in a year. And then semi-annually, as a woman, I always remember that Bath & Body Works and Victoria's Secrets have their semi-annual sale, and that happens twice a year, so it helps me remember semi-annual compounding. All right. A certificate of deposit, oops, sorry about that, is a savings instrument that many banks offer. It usually gives a higher interest rate, but you cannot access your investment for a specified length of time. Suppose you deposit $3,000 in a CD paying 6% yearly interest, compounded monthly. How much will you have in the account after 20 years? So I deposit $3,000, so P naught is $3,000. My interest rate is 6%, which is 0.06. It's compounded monthly, so I know that N is 12. And time is 20 years. So we want to know how much money you're going to have in there after 20 years. So I guess let's go ahead and write the equation because it's not on this page. So P sub n equals P naught times 1 plus R over N to the NT power. And let me move this down a little bit. You don't have to write that. It's just I didn't have it right in front of me. So P sub 20 equals P naught times 1 plus 0.06 divided by 12 to the 12 times 20 power. And that gives me 3,000 times 1.005 to the 240th power, and that gives me P sub 20 equals 9,930.61 cents. So if you're like, Amy, how do I put that in my calculator? Let's look at it. So I have a TI-83 Plus. Bought it at a pawn shop for 20 bucks. You will either have a button to raise something to a power. It's going to look like mine where there's a caret, or there'll be an X to the Y button. They'll do the same thing on your calculator. So I would put this in. Actually, I start inside. So I'd go 0.06 divided by 12. If I could actually put it 0.06 divided by 12 gives me the 0.05, and then I add the 1 to it. And then now I want to raise it to the 12 times 20 power, and that gives me, let's try this again, 0.06 divided by 12. That's better. Plus 1. Now I'm going to raise it. Oh, I got ahead of myself. To the 12 times 20 power. And then I take that times 3,000. Nope. Let's try this again. 3.310204476 times 3,000, and that gives me $9,930, and it says round. Doesn't tell me what to round, so it's $930.61. So clear as mud. We'll do the next one too. Talking and writing, talking and calculating sometimes is hazardous. It's like, walking and chewing gum. Sometimes I can be a danger to myself. All right. Savings account with annual interest rate of 4.5% is compounded quarterly. After 10 years, there's $3,910.94 in the account. What was the initial amount of the investment? Do not round until the final step and then round to the nearest dollar. Okay, so the longer you wait to round, the less error in your final answer. if you round early, you may be significantly off than your neighbor. So let me show you how I do this. So I know that R, your rate is 4.5%, which is 0.045. I know that after 10 years, so P sub 10 is there's 3910.94, and I know T equals 10 years. Compounded quarterly, so I know that's N equal 4, and they want to know what was our initial investment, what's our P naught. So I have 3910.94 is equal to P naught, using this equation up here, this one that we just wrote down. P naught times 1 plus 0.045 divided by 4 times 4 times 10. I'm just plugging the amounts into the formula, and that gives me 3910.94 equal to P naught. So if I calculate what's in this parentheses, at least I get, I'm going to put in 0.045 divided by 4, then I'm going to add 1 to it, so that gives me 1.01125. So I'm going to put 1.01125, and I know 4 times 10 is to the 40th power. So I want to divide both sides by this mess right here so I can get P naught by itself. Another good thing about waiting to calculate it is I don't have to write a big ginormous number. And so P naught is equal to $3,910.94 divided by 1.01125 to the 40th power. So how do I put that in my calculator? Well, I'm going to do 3910.94 divided by, you can put parentheses around it since there's parentheses in the problem. That's totally fine. 1.01125. On my calculator, raise it to a power, I have to use this caret, and then put 40 in, and that gives me 2499.998617, and it says do not round into the final step and round to the nearest dollar, so that would round up to $2,500. And actually, an equal sign, since we rounded, isn't the most correct. If we have an equal sign with a little squiggly on top, that means approximately. And we use that when we do rounding. Approximately covers a multitude of sins in mathematics. Alright. Liam deposits $800 in an account that earns 6% yearly interest, compounded monthly. How much will the account be worth after 2 years, assuming that Liam does not withdraw any money from the account? Round your answer to the nearest cent. So let's look at what we got here. So he deposits $800, so I know that P naught is $800. And the account earns 6% yearly interest. So the rate is 6% or 0.06, and we're compounded monthly. So I know the N is equal to 12. How much will the account be worth after 2 years? So I know that T is equal to 2. And so I need that they want to know what is P sub 2. So let's put this in our formula. So P sub 2 is equal to P naught times 1.006 divided by 12, all to the 12 times 2 power. So that would be 800. and that is to the 24th power, and let's see what we have in the middle here. So how would I do that? I would do that, I would put in, let's see where you can see that maybe a little better. I would do 0.006 divided by 12 gives me 0.005. Then I'm going to add 1, and then I am going to raise that. Well, let's go ahead and raise that. Write that down here in my problem. I'm going to raise my answer to the 24th power, and then I'm going to times 800, and that gives me $901, and I'm going to round up, so 73 cents. So that gives me $901.73. Alright, I'm going to stop this here before this file gets any bigger, and then we will do some applications.